There should not be a lot of calculations, thus we should get through them pretty quickly. The few that do have somewhat calculations are very basic elementary ones that you can be done in your head. So here, a salesperson earns a monthly salary of $500 a month. What would be another word for when they say 500 a month? What would be another word there that can be interchangeable? Per month. So that means that since it's happening every month, that 500 is acting as the slope. Here, salary depends on it's a monthly salary. Salary depends on months. So that 500 is acting as a slope, plus a percentage of the proceeds from the number of items he sells. Actually, no, you know what? I take it back. It's not the slope. It's not the slope. That 500 is a flat fee. If they were going for like a yearly or something else, maybe that could be the slope, but it actually isn't. The 500 is gonna be a flat fee, no matter what. He's making $500 a month, and then if he's making a percentage of, what does that word of mean? We know that a percent, we know what a percent is. It could be a decimal, but what does the word of mean in that context? So you use the word of. It means multiply. So that's the slope. If he's making a percentage of the proceeds, you're multiplying some percent. So let's say, this is not asking you for specific numbers, but let's say he made 10%. So that would be 10% of whatever his sales are plus that 500. So the first key thing to recognize is what type of a model is this? What type of a function is being modeled there? Forget about the drawing. We're not looking at the drawing yet. What type of, when you say $500 every month plus some percentage, yeah, it's representing a linear thing. Okay. If for some reason, like every month he was, if I guess if you could say it's growing exponentially, or if the amount he makes in the next month had something to do with the month before, if it would be a multiple of what he did before, then you could say it's exponential. But that's not the case here, so that knocks out these two. So we're left with the ones that look like lines. The difference being are the y-intercepts. D here has a y-intercept of 0, 0, which if x is months and y is how much salary he has. What this one is implying is that at the beginning of the month, he hasn't made anything. And actually, you know what? This is a monthly salary. So this would probably be days. We're staying specifically within 1 month, but whatever. When no days have passed, this implies he hasn't made anything, which is not the case. When no days pass by, like what is he guaranteed every month? 500. So the only one it could be is here, starting above 0. Again, there's no numbers being here, but the only one that it could be, which graph could be a model? If he was only making a percentage of sales, and if he was not guaranteed the 500 a month, then it could be this one. But y-intercept 500. You might say, oh, but Mr. Ra, how do you know that's 500? No, I don't know it's 500, but what I do know is that it's not 0. I do know that this is at 0. And he's not guaranteed $0, he's guaranteed $500. The y-intercept has to be off the origin, it has to be above it. Make sense? Don't make sense? This expression is showing what is a product of two factors. What does product mean? Multiply, but we already knew that because they were using the dot there. The key is when you multiply a common base. This would have been at the beginning of the year before you got to me. When you multiply a common base, what are you allowed to do with the exponents? Add them. So this whole problem is, do you know how to do 1/5 plus 3/4? Which, yes, requires a calculation, but it's something that should be able to be done without a calculator. So many of you, especially with fractions, because scientific calculators can do fractions, have become so reliant on that you forget that this should be done without a calculator. What is the least common denominator of 5 and 4? What is it? 20. 5 times what gives you 20? 4. 1 times 4 is 4. 4 times what gives you 20? 3 times 5 is 15. So 4 plus 15 is? When you multiply a common base, you add the exponent. How's the view from over there? Okay. Select all the numbers. So this would be select all that apply. That could be the sum of a rational number and an irrational number. Okay, so this was also should have been done before you guys got to me. This would have been at the very beginning of the year. But the rules were, all right, what does rational mean? If a number is rational, what does that mean? What's the root in the word rational? Well, the root in the word rational is ratio. A ratio is a fraction. So yes, a rational number can be written as a fraction. That's not a very good explanation for a lot of people to say, well, I thought everything can be written as a fraction. So a better way, I think, to describe it is in decimal form. In decimal form, a rational number will either end, what's called truncate, or it will repeat and go on forever. That's what the bar means. An irrational number goes on forever, dot, 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 it goes on forever, without repeating. So, what's the most common cause for an irrational number? What type of operation causes you to get an irrational number? If you were to put it into the calculator, that could cause the number to become irrational. No, definitely not division. Division is rational, ratio, fraction. Radicals, different types of radicals. It doesn't have to be a square root, but in algebra 1 we stick to yes, square root. So, can you ever add a square root with a non-square root and have that square root disappear? Huh? But if it's a perfect square, then that other number would not be irrational. So assuming it's not a perfect square, and that rational were there at the beginning, you can't. Long story short, here maybe I can, since you guys seem kind of bored here. Let's see. Let's see if we can do all this. Let's do adding and subtracting, and let's do multiply and divide. This was all before I got to you guys, but so let's do rational and rational, irrational, irrational, rational, irrational, and then irrational. If you add or subtract a rational with a rational, you always have to get a rational. If you add or subtract a rational with an irrational, you always have to get an irrational. Always. If you add an irrational with an irrational, I'm trying to think of a counter example, but I'm pretty sure this will always have to be irrational. When you're multiplying or dividing rational with rational, you have to have a rational. If you're multiplying or dividing a rational number with an irrational number, that result always has to be irrational. The one that's a wild card is this one. This one can be either. When you multiply an irrational with an irrational, it could be either. It could be irrational, but it also could become rational. So stuff you should know, but if you don't know, now you do know. So now we can answer this question. If we're going to add a rational with an irrational, what did I tell you up here? What's the result going to have to be? Irrational. So this one is just asking for the irrational numbers. A bar means rational because a bar means repeating. Irrationals cannot repeat. So which ones here are going on forever but without repeating? B, D. Those are irrational. All the other ones are repeating with the bar, so those are rational. You cannot add a rational and an irrational and get a rational. Sal is having a yard sale. He plans to sell old DVDs and CDs. Combined, he has 75 DVDs and CDs. He prices them at $150 per CD and $450 per DVD. Let D represent the number of DVDs and C represent the number of CDs. He sells all of the DVDs and CDs and he earns $262.50. Which of the following equations could be included in a system that reflects the constraints? So there's just a system, and it doesn't look like they're even asking us to solve. They just want us to write it. And they have defined the variables for us. D is DVDs, and then C are CDs. You can, in order to be able to solve for two unknowns, you need two equations. We can use one equation to represent the total amount of CDs and DVDs. How many do we have in total? 75. So one equation could be C plus D is equal to 75. The other equation, the other piece of information they give us is the cost. They give us the cost of each, which is important, and they give us the total amount he made. So how much is he selling CDs for? 150. So I can put 1.5 or 1.50. Looks like here they put 1.5. Change the color. 1.5C plus DVDs are 4.5D, and in total, how much is he going to make? 262.50. And they want to know which of these should be included. I don't remember if this was a multi-select. Probably wasn't. Let's see. Could it be A? No, it cannot be A. Could it be B? Yes, absolutely. That B is one of the ones I have here. Could it be C? No. Could it be D? No. Could it be E? Yes, it is. So yeah, actually, this was a multi-select. At the top of this one, it probably said, I don't have it printed here, but it said select all that apply. So that would be B and E. Those are the two equations. Any questions there? Marquise? A quadratic function. Oh, I'm gonna save this one for when the time comes back. Let's just move on to the next one. Nakai needs to see this one. Remind me when he comes back. This one. Shobi, you got it? This figure shows the graphs. The four indicated points all have integer coordinates. If g of x is equal to k times the value of f of x, what is the value of k? So what would I have to, if I were to get any, and in this, remember that this g of x and y of x, what is that? Which coordinate does that represent? The y's, yeah, you can send them up here. Those are the y's. So if I look at each, what would I have to multiply each of the y's of f of x to get the y of the other one? Well, let's look at the y's. This y here is at -1. This one here is at 3. This one, this y is at -3. This one here is at 1. So the ones that were on f of x, that's what's getting multiplied. So this 1 is turning into -3, and this -1 is turning into 3. What would I have to multiply? Either one, it doesn't matter. What do I have to multiply 1 by to get -3, or multiply -1 by to get +3. 1 times blank gives you -3. Yes, times -3. Does the same thing apply over here? Well, let's see. -1 times what gives me 3? Also -3. So this k that we were looking for here is -3. On the Google form, we would have just put -3. F of x is the line that has the 1s on it. It has these 1s. So what would I multiply that by to turn it into the y's of g of x? Based on the graph of the function, which statements are true? Okay, look at all these words. Increasing and decreasing. When you use increasing and decreasing, what you're assuming is that you're going from left to right. And really what you're looking at is at the slope. But instead of being that technical, just think of it like a roller coaster. And then they're asking you is, where they're at, like whatever interval that they're referring to, are you going up on the roller coaster, down, or neither? So let's see based on this graph, which is true. We're looking for which one is true. So f is increasing on the interval x is less than 0. Now remember, we're always going from left to right. So when x is less than 0, what I'm looking at is only this part of the graph. If I'm going from left to right and I were on a roller coaster here, would I be going up on a roller coaster? Is that roller coaster headed up? Yes, it is. So A is an answer. F is decreasing on the interval x is less than 0. Well, no, you can't be both. This roller coaster, if we're going from left to right, is going up, so it can't be B. F is increasing on the interval 0 to 2. So now let's see if we look in between 0 and 2 on the x. Here's 0. 2 is up here. So this part. Is the roller coaster still going up there? Here's little Nakai. He's on the roller coaster. Whee! So now we got up to here. If he continues to go from left to right, is he going up or is he going down? Yeah, on that little strip of roller coaster that I just highlighted, he is still going up. So he's still increasing from 0 to 2, which is C. And if it's C, it can't be D because D says decreasing and we're not decreasing. Okay, now let's go to the next little piece of the roller coaster between 2 and 4. Notice how what we're talking about here are the x's. Everything has to do with x. So between 2 and 4 on the x-axis, maybe instead of highlighting, maybe if I did this, it would help you see it better. On the x-axis, between 2 and 4, so on this little strip of roller coaster now, would Nakai be going up or down? Now he'd be going down, so this is decreasing. Anytime they use these words, increasing or decreasing, they're talking about left or right. So it'd be decreasing, and then finally at the very end, when x is greater than 4, that one should be obvious. That's at the very end of the roller coaster. Is he still headed down or going up? Down. So the ones you would have selected there are A, C, F, and H. Okay. I saved that one for you. I'm going to go backwards. A quadratic function is shown. They give you one factor. You have to find the other one. So instead of worrying about all this other stuff, let's worry about this. Do you know how to factor that? What is getting in the way of us being able to factor this right now? What should you not even attempt to try to do? Has it been that long since we factored? Why do I not want to factor it the way it currently looks? A is negative. I don't want A to be negative. So what I'm going to do is factor out that negative. If I factor out the negative, I can make change every sign. So x squared becomes positive, 7 becomes negative, and the 12 becomes positive. So now my A is not -1, my A is 1, B is -7, and C is 12. We always like it when A is 1. That way we don't have to do any special steps. Can you think of two numbers that multiply to give you 12 and add up to -7? They've already given you one of them. -4, sure. -3 times -4 gives you positive 12, and again it gets -7. So if I were to completely factor this, I would have the negative on the outside, the x minus 3, and the x minus 4. So in reality, this function has three factors. It has the negative, the x minus 3, and the x minus 4. They already gave you the x minus 4. The negative was not one of your choices for the answers. If you look down the list of answers, that was not one of the choices. So what's the one you would have picked? X minus 3. Questions there? A product of two numbers is 323. The difference between them is 2. What are the two numbers? It's a system. Yes, this requires calculations, but it shouldn't be anything that's out of the ordinary. First, we got to define two variables. They want two numbers, so let's let x be one number. Let's let y be the other number. The product of the two numbers is 323, so that means xy is equal to 323. The difference between the two numbers, what does difference mean? Subtract, and it doesn't matter. You call one of them, you call one the other. It doesn't matter. But let's just do the, x is equal to, x minus y. The difference, x minus y, is equal to 2. So now we want to solve. What were the two? Assuming that we're not going to graph this. What are the two algebraic methods for solving systems of equations? If you have two unknowns, you need two equations. I just wrote two equations. What were the two algebraic methods we learned? Substitution and elimination. We cannot use elimination here because here the x's and the y are being multiplied. I'm going to have to use substitution. And you're not going to want to substitute this because that means if you have to solve for either one of these, you're going to have to divide and that's going to cause a fraction. You're not going to want to deal with that fraction. So I would tell you, let's solve for either the x or y down here. We'll make it simple. Let's just solve for the x. That way y stays positive. So x is equal to y plus 2. You follow me so far? If I now get that y plus 2 and plug it in for the x in the other equation, that would give me y times y plus 2 is equal to 323. What type of equation is this about to become? It is going to become quadratic. Because once I did, if this equation would have been equal to 0, I could solve already. I could just use zero product property and split it. But because it's equal to 323, I'm going to have to put everything on one side. Y squared plus 2y is equal to 323 minus 323. So I bring everything over to one side. You could use quadratic formula, but that could cause you some trouble with that 323. That might be too big of a number. And then especially when it comes to square roots. So I would probably try factoring here. I realize you don't have a calculator, but A is 1, B is 2, and C is negative 323. So we're looking for two numbers that multiply to give you negative 323 that add up to 2. Well, I know 1 and 323. 3 wouldn't work, 5 wouldn't work. 7 might work. Let's see. 17 worked? So you just did it by trial and error because of the multiple choice and you figured out which one. What he's saying is 17 times 19 gives us that. Yeah, it would have been a little hard to find, but fine, let's just say You wouldn't probably have to do the long division. Maybe I should have picked easier numbers here, but maybe put this on the calculator part. But he said 17 and 19. Um, but now the thing is, though, in order for this to happen, the 17 has to be negative, and the 19. Can somebody that has a calculator confirm that for me? 17 times 19 should give you 323. I probably should have put this in the calculator part, but you could have also done what he did, which is just trial and error. So that gives me y minus 17, y plus 19 is equal to 0 still. When I make each one of these equal to 0, I end up getting y is 17 and y is negative 19. Which negative 19 does, you can't have somebody be negative 19 years old. But if I know that one of the ages is 17, okay, and specifically that the y is 17, when I go back and plug that in, up here for x, what is 17 plus 2? 19. What Nakai just did is he just said, well, hey, look, those two numbers satisfy both criteria. 19 minus 17 gives me 2, and 19 times 17 gives me 3. It works if you're given multiple choice. Which expression is equivalent? All right, so this is just removing the parentheses and looking for like terms. 3x to the 5th plus 8x to the 3rd minus 7x squared plus. That would be what would trip you up. Is that, remember, when you have a negative on the outside, you're supposed to change the signs so the 6 becomes positive. You combine like terms, this just drops, so 3x to the 5th minus, next. I have to combine these two. 8 and 6 is plus 14x to the 3rd, and then minus 7x squared. Which graph best represents the solution here? I don't think we did these here, but I know other schools cover this. So, look, the thing is, what we did cover individual inequalities. So, like, you should know what the graph of this, or at least the boundary of this looks like, and at least that. I would want to get y by itself. So this first one would be y is less than or equal to negative x plus 6. And this other one here, let's see, would be 2y less than or equal to negative x plus 8. And then once I divide by 2, I get y is less than or equal to negative 1/2 x plus 4. So because they're both, they both have an or equal to, both lines are supposed to be solid, but all of these have solid lines. I'm looking to see one of my boundaries should cross through 6, and the other one should cross through 4. So that's the next thing I would focus on. Which one of these has both has a boundary crossing through 6 and a boundary crossing through 4? Looks like it's only one of them. Huh? Yeah, it looks like these are the only one. But then if you wanted to confirm it now where the shading is, the shading has to be true for both. When you draw 2 lines on a plane, how many sections does that break the plane into? How many different sections are there? How many different sections are there? 4. So, and if you remember when you were with me, like we did one at a time, but we talked about, hey, there's somebody walking up a hill. Do you shade the sky? Do you shade the ground? So whatever ends up getting, which you can only shade one of the 4 sections, and that one section has to be true for both. If you look at both of these, on both of them, the y is not getting eaten, so you have to shade the ground. So if these were 2 different hills, if here's a hill for one person and then here's a hill for the other one, the only area where that would be the ground for both is what's shaded in here. That's the only reason that's true for both. We didn't cover it here, but I know other schools do. We'll just kind of cross that bridge if we get there. No reason, dude. If I ask you to only graph this, you should know how to do it. If I ask you to only graph this, you should know how to do it. So all this is doing is you're putting two on one graph and saying, here, perfect, look, watch. This is the only other way I can describe this. Let's look at the first one, negative x plus 6. Okay, 6 is the y-intercept, and the slope is negative 1 over 1. So I'm just going to focus here on D because I know that's going to end up being the answer. It's already drawn for me there, right? If I were to only graph that, that function there, which is this one crossing by 6, I'd be shading all of this. Pretend that the other one isn't even there. What color am I shading? What color am I shading? What color is that? Yellow, right? Yellow. Okay. So what I just shaded is just this graph right here. If I were then to say, you know what? Let me shade this graph only, but in blue. If there's going to be a section that is true for both, it would overlap. What happens when you mix yellow with blue? What do you get? I'm not drawing in green. Remember, I'm not drawing in green. Let's see what's happening. I'm going to go to the one over here. That's just for the four. Whoa. Uh-oh, look at that. I'm drawing in blue, but where there's an overlap, what is that turning? It's turning green. The white section is not true for any of them. It's false for both. The yellow section is only true for the first inequality. This little blue section over here is only true for the second, but what ended up turning green is true for both. That's why that ends up getting shaded. Let A represent a non-zero. Okay, so we're back to rational, irrational. You might want to refer to the thing which expression could represent a rational? So they're saying we have one rational and an irrational. And B is the irrational. So can a negative irrational be rational? No, can't be this one. If I add a rational with an irrational, can I get a rational? No, I told you no. We wrote that on the page. I told you no. When you multiply a rational with an irrational, could that be rational? No. If you square an irrational, could that be rational? Yeah, you could. It's the same as multiplying times itself. I told you the only towards the end there that it could be either one. It could also. Could is the word. It doesn't say will be. It says could be. If you multiply an irrational times itself, that one could be rational. Another way of thinking it, what type of symbol causes irrational numbers? I wrote it on the board. What type of operation? The radical, right? In which in Algebra 1 we deal with the square root. What does a square do to a square root? It cancels it. The square would cancel the square root. Sam, let me know if I know I'm righty, so sometimes I block the board. Let me know if I'm. The manager of a coffee shop suspects that the outside temperature decreases in the evening. That when it decreases in the evening, the number of hot beverages she sells will increase. The manager creates a model to see if this is true. What are the most appropriate variables in the model? So this is just identifying what's the independent and what's the dependent. Does the number of beverages she sells depend on the temperature, or does the temperature depend on the beverages? If she decides, hey, you know what, like, hey, I'm not going to sell as much, does she control the weather and then it's going to get colder? So which one here would have to be the independent? Which is the one that, regardless, it is beyond our control? The temperature. And then based on that temperature, the amount that they sell would be the dependent. So independent would not be beverages sold. Independent could be outside temperature, dependent number of hours. I like this one so far, but we'll read through the rest. Independent, no, this can't be. And finally, independent average evening outside temperature. Okay, so it could be B or D. So let's see if we can dissect these two to see what the difference is. So the independent would be the hourly outside temperature. Okay, so the only difference here is the word hourly versus average. What do you think would be a better independent variable? Looking at it by each hour or looking at the average? At the hour. Yeah, looking at specifically by the hour, because on the average, maybe late at night it gets super cold, but early. Remember about what is the average more susceptible to when we study data and statistics? What are averages more susceptible to? To extremes. When you have an extreme, that could affect your data model. So maybe late at night, again, the temperature just dropped all of a sudden, but early in the evening, she wasn't really able to sell much sun because it was too warm. So the better one would be to look at by the hour. And you look, okay, how many did you sell at 7 o'clock? How many did, especially because she's looking to see, you know, if it affects how much she's selling. So she probably want to look at it by the hour. The annual average temperature of a location depends in part on the distance from the equator. They've already modeled this for you. What is the meaning of the constant term? So the constant here is 90. They just want to know what the 90 means. They gave us a line of best fit. So what type of a function is that? When I say 90 minus x, what type of a polynomial is that? It's linear. So what is the 90 taking the place of? So the 90 is the y-intercept. Constant is the y-intercept. So we need to know that on any function, even if it wasn't linear, a y-intercept is what happens when x is 0. X is the degrees of latitude, and its distance from the equator. So if that x was 0, the latitude at the equator is 0. Science the line of best fit for the data. So it looks like y is going to be the annual average temperature of a location, and it depends on distance from the equator. So if distance from the equator was 0, that means you would be on the equator, correct? Now the y-intercept is the y value. What is y measuring? If I just told you that distance from the equator is x, average temperature would be y. The y-intercept is the value of y. It's still a y value, but it's the y value when x is 0. So if we are 0, what is it, miles? Let's say, we can say it's 0 degrees. We're measuring it in degrees latitude. Don't get that confused with degrees Fahrenheit. So if we're 0 degrees away from the equator, we're standing on the equator. The 90 is a temperature. What does that mean? Yeah, that it should mean that it's that's the temperature at the equator, which is 90 degrees. If you're standing on the equator, the average temperature is 90. It can't be a rate of change. Rate of change means slope. It has nothing to do with number of different locations. It is the rate decrease of 1 degree in temperature. It's not a rate. Rate is slope. So 90 is the temperature when you're on the equator. Which is a graph of the solution of this inequality. So here, look, read, this is what we're talking. This we did do. This is something that we did do. Where now we just graph one inequality at a time. You're still going to want to solve for y. You want to get y by itself. So minus 3x minus 3x. So negative 4y is less than or equal to negative 3x plus 24. Once I divide by negative 4, besides knowing how to divide, what else do I have to know how to do? If I divide it by a negative in an inequality, what does that mean? I gotta flip the inequality sign. So I end up with y greater than or equal to Negative divided by negative is positive 3 over 4x, and then minus 6. So I'm looking for a boundary that crosses through negative 6 and has a positive slope. How many of these graphs does that apply to? To 2 of them. Both B and C have a positive slope and is crossing the y-axis at negative 6. The next thing I would look for is the slope. If that positive slope is 3 over 4. So let's see. Up 1, 2, 3 over 4. Yep, that applies. Up 1, 2, that's on 3 over 4. So they both have the same slope. So what's the only difference then between B and C? Where the shading is. If this was a hill, okay, this one up here would be the sky. If somebody's climbing up a hill, this is where the sky would be, and this is where the ground would be. Here, mouth eating Y. Mouth eat Y, Y big. So do I want to say the sky or the ground? The sky. Mouth hungry, mouth eats big numbers. Mouth is eating Y, Y big, shade the sky. Yes, we did. Write this expression using rational exponents. Okay, this is an easy one. This will definitely belongs in a no calculator section. The formula here says x to the a over b is equal to the b root. This would have been done before you got to me also. It's just knowing that this number here is called an index. As a fraction, that becomes a denominator. Whatever this is, the exponent stays as the numerator. So if I were to apply it to this, the 10 stays as the base. What number becomes the numerator? What number becomes the numerator? The 8. What number becomes the denominator? What's the index? Every radical can be rewritten as a rational exponent. In this equation, A, B, C, and D are real numbers. Which of these equations could have solutions that are non-real? In these equations, A, B, C, and D are real numbers. Which of these could have equations? Which of these could have solutions that are non-real? I know we didn't. I shouldn't have put that. It's a bad question. That's more algebra 2. Maybe I misread it when I did. Here we study the difference between rational and irrational, not real and non-real. This was curved anyways, but that's my fault. I'm sorry. Just don't worry about that. Let's just skip that. Which of the following do not have integer exponents when rewritten as in rational exponent form? Which of the following do not have integer? So an integer is a number that doesn't have a fraction or decimal. So like if I were to rewrite all of these, we know the exponent and we know the index. The only one that's not written is here, but we know that on a square root of 2. So we look at the first one. This is s to the 4 over 2. This is s to the 3 over 6. This is s to the 6 over 4. This is s to the 9 over 3. This is s to the 15 over 5. This is s to the 2 over 8. So which of those, when I divide them, would they not divide evenly? Does 4 divide evenly? Does 2 divide evenly into 4? Yeah, so it can't be 8. Does 3 divide evenly into 6? Or sorry, vice versa. Can I divide 3 by 6? No, I would be stuck with a fraction. It's not an integer. It's 1/2. So B is an answer. Can I divide 6 by 4 evenly? No, that would give me still a fraction. Can I divide 9 by 3? Yeah, I could. Can I divide 15 by 5? Yeah. Can I divide 2 by 8? So it's B, C, and F. When I was at Brookwood, I did this with the kids. And did I get from your facial expressions that you guys did not cover this in the beginning here?
No.
You did or you didn't?
Didn't.
Did not, no. Several points are plotted on the graph. Which of the plotted points represent zeros of okay? So this we did. What's a zero of a function? Say it again? X-intercept. We already know one x-intercept from this factor here. What's going to be one of the x-intercepts? If x minus 6 was equal to 0, what would x be? It would be 6. So that's B. Now the only other thing I have to do is factor this one. What two numbers multiply to give me negative 8 and add up to positive 2? Positive 4 and negative 2, which means if I made each one of those equal to 0, I would also get x is equal to negative 4 and x is equal to 2. So my zeros here are 6, I knew already, negative 4 and positive 2. So which one would that be? It's 2, 0, 6, 0, and it's negative 4. Even if you were to guess, you know that. Why do you know that it can't be these? Yeah, those are y-intercepts. The zeros would be x. Rewrite this expression to find the coefficient. So this is just simplifying, and then you can pick all the numbers. So when I simplify, this gives me negative 3a squared minus 3ab plus 15a minus 8a plus 8b plus ab plus 3b squared minus 7b. So I end up with 1, 2, 3, 4, 5, 6, 7, 8 terms. Are any of those like? Yeah, they have to because I only have 5 spaces. So it's figuring out which ones are like. As far as the a squares go, I only have one of them. So this, congratulations, this gets to be negative 3. Right? As far as the b squares go, I'm going to do a b wrong. No, I have it over here. The b squared is 3. So that would have been one of the boxes you checked. The AB does have like terms. Negative 3 and positive 1 is negative 2. So this would be negative 2. For the A's, I have 15 minus 8, which is 7. And then for the B's, 8 minus 7 is 1. Those would have been the 5 numbers you picked. All right, let me just finish this one here real quick. A system. Make these equal to each other. That's substitution. I plug in one y for the other. If you need any more help with any of these, you gotta just see me during odd hours. 3x is equal to negative 3. So x is negative 1. If I plug that into either one, let's plug it into the first one. What is negative 1 plus 2? 1. So that's what you want to put in. Put 1. So there's a bunch that were missed. If you want to, if you're genuinely confused about any of those other ones, come and see me before school, and I'll be happy to go over with them one-on-one.